So a set is a collection of object. Basically, in our course, the object will be the numbers.
Okay.
All right. We'll work with the numbers. So let me tell you the numbers before go to the okay. So set are represented by listing all of its elements. So sets are represented by listing all of element inside a bracket or specifying the property of elements without listing, just will specify the property, that property satisfied by the element.
Okay.
Yeah, so let me tell you example, so then you understand. Example, x is the set of all even numbers between 1 and 10. Okay, so we will
Okay.
represent, yeah, in two different way. X, first listing all element, we list all even number in between 1 and 10. Yeah, so the first number will be
Mhm.
2, yeah, then c 4 6 8 10. Okay, this is
Okay.
the first process. Yeah, the second process is what, the the identifying the property. So we write like this: x such that x is natural number. So let me tell you here, even natural number, yeah, with the condition 1 less equal to x less equal to 10. Okay, right.
Okay.
So that way we can represent the set. So collection of element they will
Mm.
provide you, and they asked represent as a set. So either listing element or just x, such that x satisfy the property like that. Okay,
Okay.
fine. So yes, so in this course, since we will work with the numbers, so let me tell you fundamental set basically. Okay, yeah. So n, the set of all natural natural numbers. So how they defined? They defined the listing. You can list them 1, 2, 3, 4, dot 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 this way. Okay. So W is the set of all. So I have to introduce this. Otherwise, after introducing this, I will go to the function, all the thing. Okay.
Okay.
Set of all whole number. So just to include zero.
Okay.
Yeah. And the G, yeah, the set of all integers. So they are basically zero, including the minus also. So plus minus 2, plus minus 3, dot, 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 dot. One thing I include here, that see, we can add two number here, right? If I give you two natural number, then you can, make another natural number by adding those, right? So you can add, you can multiple, right? But subtraction and division not allow, right?
Yeah.
And we have a less than here. Yes, this allow here. And here we have addition, multiplication, and less than. We can give a order, right?
Yeah.
Or okay. So here what we can do, extra plus, and we subtract, we multiple, and we can give a order. But division not allow, right?
Mm.
Okay, fine. So let me go to the next. The next is the Q, the set of all rational number. So how they defined? So they are defining by the ratio of two integer, right?
Okay.
Yeah, fine. So basically they are of the form P over Q such that yes, I am not listing because it is not possible. PQ, okay, so PQ, PQR. So I mean, let me write down like this, belongs to Z and Q not equal to 0. For example, 2 over 3, 5 over 7, negative 2 over 7, like that. Okay.
Mhm.
Okay. And
Okay.
now, yeah, now the next is set of all real number R. So what we do, we just include all irrational number with rational number. Then we get all real numbers. Yes. Okay. So here we have rational U and more if we add here all irrational, right?
Yeah. Okay.
Irrational mean what? Irrational mean square root of some number, nth root of some number, pi, e, all those things, right?
Yeah. Okay.
Okay, fine, very good. So now let me go to the next concept, that is the cardinality of a set. Oh, okay, before go to the
Oh,
cardinality, yeah, let me introduce function. Okay, so function mean you will have two sets. So you have a set A, you have another set B. Okay,
okay.
right. So A, B two set given. So now a function. Oh, one thing I forget to tell you. Do you know the concept of subset?
Yeah. Yeah.
All right. So A subset B, this we use. Also, I'm going to use the interval notation. Interval. Do you know the interval? Interval mean A comma B.
Uh.
Yeah, tell me.
Oh, yeah. This is fine. Yeah.
Okay, 2 comma 3 mean all the number between A and B, right? Such that all number we take between A B. So one second. So now if we take open A comma B, here the open, so then this means X such that A less than X less equal to B. Do you know this kind of thing?
Yeah.
Oh, okay, good, right. So we have two set A B. So a function from A to B is a rule F such that if you take any element here X, you will get a unique element here Y. Okay, by the rule F. Okay.
Okay.
Okay. A function is a rule that assign every a, that assign a unique element an unique element of B for each element of A. So if you take element from A, sorry, 2 seconds. So any noise are you getting?
Yeah. A little bit, but it's okay. I can hear you.
Okay, all right. So a function mean if you take any element from A, then you get a unique element in B. Okay, that's
Okay.
so that we write y equal to yes fx. So many way you can give the function, either you can give the formula for fx or some diagram. So if your set A is finite, then we get a B finite, then we give a diagram. Okay,
Okay.
like that. Okay, so the rule, basically you can think you have a formula. You can think you have a formula here fx. You have to put here x. Now which x you will take, that is interested here. I mean, we are interesting to find out those x for which fx is well defined. Okay,
What do you mean by well defined?
well defined mean, for example, if I asked you the square root of x,
Hmm.
in the place x, which number you can put? can we put negative number? Is it possible?
No.
No, because square root of negative number we cannot calculate in the real number, right?
Hmm.
So only thing we can take x positive. So x 0 or greater than 0. Got it?
Got, yeah.
That yes. Right. So there are some special function. I will tell you for those special function what value of x you can put on that. Okay.
Okay.
For example, square root of x. Then let's say ln of x. Here you can put x positive, negative not allowed. Okay.
Hmm. Hmm.
If I give you x plus 1 divided by x minus 2, then which value you cannot put in the place of x?
2.
2, because you get 0 below. So that is the problem.
Yeah.
So yeah. So the domain of this function will be all real number except 2, right?
Yeah.
Okay, that's the thing. So we'll see. Okay. So let me tell you some standard function and their domain. A is called the domain. Okay.
Okay.
Right. So let me give an example. So if I give you a set, let's say you have a set A having 3 element, 1, 2, 3. And let's say B having 2 element, A and B. So now let's try to write down a function from A to B. So that we can write here. Basically, you have here A, here B. So you can make a diagram because you have a finite set. So here 1 you have, here 2, here you have 3, here you have A, here you
You
have B.
know finite set.
Yeah, sorry.
How do you know it's a finite set?
I'll tell you. Finite set mean if the number of element is finite, if you start counting and if you stop at some time, then you say the set is finite. Okay.
Okay.
So here, how many element has in the set A? 3 elements, right?
Hmm.
In the set B, how many element you have? 2 elements. So they are finite set, right?
Yeah.
But if I give you this set, 2, 4, 8, 6, 8, if we take this pattern, then you know this pattern never stop, right? Then you get so
Hmm.
even number. So it is infinite set. Got it?
Okay.
I'll tell you. I'll come to this. This is called the cardinality. There is a notation. I'll tell you
Okay.
before go to this. Yes. Let me finish the function. Few functions, standard function. Okay.
Okay.
Right. So let's say we have a is clear the finite set and infinite set.
Yeah, yeah.
Okay. If the number of element is finite, then you call finite set. If the number of element is not finite, I mean infinite, then you called it is infinite set. Like that. All right. Okay. For example, if I ask to write all the number between 0, 1, how many number there are in between 0 and 1? Finite or infinite?
Finite.
No, infinite. There are infinitely many number in between 0 and 1. All real number, right? So
Oh, okay, okay.
you can take this, you can take this, you can take this. Many, infinitely many number there are, right?
Hmm.
You can take 1 over 2, 1 over 3, 1 over 4, 1 over 5. You never stop, right?
Hmm.
So therefore infinite set. So the interval 0, 1, this is infinite because it contains infinitely many numbers. Okay.
Okay.
Okay. So yeah. So here we have a set having 3 element 1, 2, 3, and here we have a set B having 2 element AB. Now you can write down many function from A to B. I'm giving one example. Just you join, you take a element here, join with a element here. So yeah, you have two choice. Take any one of them. So I'm taking this. Okay.
Hmm.
Now, but you cannot take for one, you cannot take select here two. You have to take only one. Okay. I mean, for the one, you can take here only one element in the set B. Either you can take A or B. For example, I took here A. Okay.
Okay.
Now, for if you take two, yeah. So then you have two choice, either A or B. So let me send to A. This is a function. Now three, you can send to A or B. So let me send to B. Got it?
Okay.
So if you call this is your function f, then f we write like this: a to b. How it is defined? Is given by f of 1 equals to a, f of 2 equals to b, sorry, a, f of 3 equals to b. Is it okay?
Yeah.
Right. So you can define many more ways. So let me use the black color. So you can send a to, let's say I am taking sending to a. So let me give same thing with another, the situation. So 1 2 3 here, a b. So what you can do, let me first send a to b, 2 to b, and let's say 3 to a. That we can do, right?
Yeah.
So this is this function called g, like that.
Okay.
So this is function. But if you draw one element, if you connect one element of a with at least two element of b, then it is not a function. Okay. So suppose you join one here, also join one here, and this is here, and let's say this is here. This is not a function because one has two image, a and b. So this is not a function. Got it?
Mm. Yeah.
You need only one element inside b, like that.
Okay.
Okay, fine, good. So since finite set, you can represent using this diagram, like that. For infinite set, you have
Mm.
to write a rule, a formula. Okay.
Okay.
So let me tell you here. So we have a set A. Let's say it contain all natural number 1, 2, 3, 4. It is a set of all natural number n dot 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 dot. Yeah. And B set, let's say, given by all even number 2, 4, 6, 8 dot dot dot. Okay.
Okay.
Right. So we want a function from n to a, n to b. We want a function. There are many functions. We want to write one function. See here the problem, n set has infinitely many elements. B set has also
Mm.
infinitely many elements. Forget about the B set. N set has infinitely many elements, right?
Mm.
So you have to first find out what is F1. That formula you have to find out. What is F2? That also you have to find. What is F3? It is difficult job, right? To
Yeah.
listing all elements this way. What for this case, A was a finite set, so we can draw the diagram and just join them, and we can explicitly
Mm.
write down all images, right?
Yeah.
But here the problem, I mean, not problem, you can draw the diagram, but from the diagram it will not be clear. So one function
Mm.
I can give here. See, I am sending 1 to, let's say, 2. I am sending 2 to, let's say, 4. I am sending 3 to, let's say, 6, and let's say 4 to, let's say, sending 8, like that. Okay.
Mm.
Okay, so what I am doing, 1 I am sending to 2, 2 I am sending to 4, 3 I am sending to 6, 4 I am sending to 8. Are you getting any, the rules here that maintaining?
Yeah.
What the rule? So for example, if you take variable x here, then where we send x?
2x.
Ah, good, good, good. Nice, nice. So this formula we have here. So just in general, we write by, this is given by fx equal to 2x using the variable. Fine. Okay.
Okay.
Right.
Mm.
Now, you know, actually, let me define the cardinality. So I think it's okay. The function concept is clear, right?
Yeah.
Okay. So let me go to immediately injective function and surjective function. Okay.
Okay.
Right. So here, always function, when you will work with function, there will be two things: the domain, the first set, and the codomain, the second set. Now, from the first set to second set, you are assigning a rule, right? If you take any element inside
Mm.
first set, yes, you get a unique element in the second set. That either they will provide in the question fx equal to the formula, or they will ask you write down the formula. How you do that?
Mm.
Just, yes, looking at the structure of the element of a and b, you can do it. For example, here you use the common sense and you write down a formula here, this, right?
Yeah.
All right, fine. Just looking, this is 1, 2, 3, 4. These are nothing but the twice of that, the first set. So one basic
Yeah.
function we can claim, yes, fx equal to 2x. All right. Okay. So let me tell you the some function. Then I come back to the the injective and surjective. Okay.
Okay.
Some special function. Yes, that we use in this course. Here it is. So let me list it here. So first that function I will tell you the number one, the linear function. Okay.
Okay.
Yeah. So how it is defined? Where you send x, fx equal to, it is given by ax plus b. Okay. This kind of function called the linear function. Hmm.
Okay.
So you are saying yes, x to ax plus b. I am telling here example for your understanding. So here example. So f, first I have to take a set, let's say n. I mean it contain 1, 2, 3, 4 like that. N to n. By how? Let me take by fx equal to 2x plus 3. Okay.
Okay.
Okay. So see, is it a well-defined function? I mean, if you take any natural number here, are you getting here always natural number?
Yeah.
Yes. So x is a natural number. If you multiply by 2, then again getting natural number. Add 3. So natural number. So that's why. Okay.
Hmm.
Very good. So this
Okay.
is a function. Good. So now if I give you g, let's say n to n by this formula, gx equal to 2x minus 3. Is it a function well defined?
No.
Why it is not a function? Can you tell me the reason? What value?
Because I will not get natural number when I
You cannot
put.
put 1. You can put after 1. So 2, 3, 4. Then you getting natural number. Exactly. Okay.
Hmm.
Got it. Good. So the let me tell you. So now if I asked you what is the domain of this, the linear function, in the place x, it's you can put any real number, right?
Hmm.
It is well defined, no doubt, right?
Yeah.
Okay. Now let me tell you the quadratic function. So quadratic function, how it is defined? Fx equal to, it is defined by ax square bx plus c. So it is a degree 2 polynomial, right?
Yeah.
Okay. So now next, let me tell you the polynomial function. And all these functions defined for all real number. Okay. I mean,
Okay.
yeah. Most of the time we think these are the function from R to R, R to R. Okay.
Hmm.
R to R like that. Yes. So polynomial function how defined? It will be a n degree polynomial. So an some coefficient x to the power n, an minus 1 x to the power n minus 1 like that. Dot 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 a1x plus a0. Got it?
Okay.
Degree n. Have you seen this kind of expression before?
Yeah.
Okay. Just I put here degree 1, here degree 2. When we will write down degree 3, we have to take three numbers a, b, c, d. In general, if you take n degree, then you have to take n plus 1 number. An minus 1, dot dot a1, a0, like that. All right. So the domain of all these function, are real number. You can take. Now the fourth function
Hmm.
is the square root function. Okay. Square root function. So how they defined? Fx equal to square root of x. Got it? What
Okay.
is the domain? Domain of f. What value of x you can put here? X such that x greater equal to 0. So this is nothing but 0 to infinity. Okay?
Hmm.
Right. Okay. So if I write down here, let's say fx function equal to square root of x minus 2. Can you tell me the domain of this function? What you have to do?
Yeah, it has to be greater than 2.
Yes, greater than equals to 2. You can put also 2, right?
Oh, yeah, yeah.
Just see here. I wrote in general, if you have square root of x, whatever you have inside square root, make greater equal to 0. So
Mhm.
x minus 2, yes, greater equal to 0. From here, what should we get? X greater equal to 2. Okay,
Yeah.
right. So now let me tell you next function, that is the logarithm function. So logarithm function is basically how defined? Fx equal to ln log, sometime take log of base 10 and here x. I mean log of some base a will be there. Okay. Domain f will be what? All positive number. So
Okay.
whenever you have logarithm function, domain will be all positive number. Okay. So there is some special function called the ln x. So this is nothing but the logarithm of x base e. So what will be the domain? Domain of ln function? It will be all a same thing. Got it?
Okay.
All right. So the now because you know in the homework you have this kind of question, right?
Mm.
Domain, a composition of function. When I explain, you can see there these kinds of thing we will use. So now let me tell
Yeah.
you next function. Yes, trigonometric function. Okay.
Okay.
Yeah. So
Um, I want to ask, did you see the solutions that I sent you from my
yeah,
friends?
I saw some mistake there are
Oh, okay, okay.
some mistake. Did you solve by yourself?
I was trying to solve, but I was not able to. That's why I wanted to help with this.
Oh, if you look at my
I
solution,
want
then
to,
hmm?
yeah, I want to like go over your solutions with you. Like I want to go over them one by one, all the questions.
Okay, okay. So what I do now? We'll start solution or just concept first, then we go to solution.
Maybe just go over the main concepts that I need to understand the questions. Like most of the questions have like
Same time.
the pre-image, the projections, and all these things. So
Oh,
just these concepts go over.
all right. Okay, I got it. Got it. So whenever this kind of function we will encounter, we will explain this. Okay.
Okay, and I will show you. I sent you the book, right? That
Yeah,
we
yeah,
have.
yeah, yeah.
Yes, my quiz would be from the lessons. I will tell you. So it's from 3.2.
Oh, 1 second, 1 second. Let me find out.
Okay.
3.2. Okay. 1 second. Let me find. What is 3.2? Yeah, three.
Projections.
Okay, 3.2,
So 3.2 until 4.3.
4.3. Okay, okay, okay.
So
Fine.
all these lessons.
Oh,
Okay.
okay. Good. So let me tell you the. I just, I was talking, all the concept. That's why I took time. So okay, let me go to that one also. After finishing this, I would come to. Okay, let's start there. Okay,
Okay, fine.
right. So let me tell you here. So injective function. So injective function mean a function you called injective function if two distinct element has distinct image. Okay.
What do you mean by image? Like the drawing?
Yeah, drawing. Yeah, is
Okay.
yeah injective. So let me write the definition, then you understand. If
Okay.
yeah, if xy x1 not equal to x2 imply f of x1 not equal to f of x2. Got it? So this means,
Okay.
yeah, if you take here two distinct element, they will map to two distinct element. These two are distinct. This kind of thing you have. Okay.
Okay.
Right. So 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 this expression you can write different way. So you can start f of x1 equal to f of x2, and if you can check if this imply x1 equal to x2, then this is the same thing, right?
Yeah.
Okay. So most of the time we will use this to check some function injective. Okay.
Okay.
I mean, we consider f of x1 equal to f of x2, then we will check x1 equal to x2. If we can check x1 equal to x2, then we say, okay, the function is injective, right? So,
Okay.
yeah, in the diagram, let me explain one example. So, you have the set A, here B, and let me here you have the set A, and here let me set B. So, here we have 1, 2, 3. Here, let's say A, B, C, D. Here, 1, 2, 3, A, B, C, D. So, yeah, let me join this to this, this to this, and this to this. And here let me this to this to this, and this to this. Got it?
Okay. So these are injective?
Okay, yeah. Which one is injective? This is, let's say, f a to b is given by this, and this is, let's say, g a to b is given by this way. Check which one is injective. F is injective?
G? No.
No. Yes, because 2 and 3 different, but their image are same, so not injective. Yes, F is not injective. G is injective.
Yeah.
Yeah, this is G is injective. Okay. Okay. Now let me tell you, you have a function, that formula you have. Then using formula, how you can check it is injective or not. Okay.
Oh,
Right. So let's say f, you have a function from set of all real number to set of real number by fx equal to x square. Okay.
okay.
Is it injective? Is f injective? That we check.
Mm,
So R contain all real number, positive, negative, everything. The formula given by fx equal to x square, right?
mm.
So can you check it is injective or not? So can you find two distinct member here? They map to the same element.
Um,
Yeah. So let me tell you. Take two element, 1 and negative 1. So where 1 map? F of 1 equal to 1 square. So this is 1. What is f of negative 1? So that is negative 1 square. So 1, right? Is it okay?
so it's not, yeah,
Yes.
so it's not injective.
Exactly. Not injective. So it is not a injective, right? Because 1 map to 1, also negative 1 in the domain, it map to 1, right?
Yeah.
Okay. Now this, if I give you here second example, so let me take the function f from all positive real number to r by fx equal to x square. Then is it injective? You are taking square, right?
Yes, it's injective.
Yes, in this case it is injective because negative, you have no negative number. So the problem was the negative number, right?
Yeah.
So it is injective. Okay, okay, fine. So let me tell another example here. So let me give an example here. So f, let's say from n to n, is given by fx equal to 2x plus 3. Okay,
Okay.
is it injective?
Uh,
Yeah. With
yes.
okay, how you check, how you write the solution? So the solution, how you write, you have to start. Yes, you are correct, it is injective. F of x1 equal to f of x2, you will start with this. Okay,
Oh,
yeah, so this imply what? 2x1 plus 3 equal to 2x2 plus 3. Then what should we get? 3 cancel out, so we get 2x1 equal to 2x2. 2 cancel out both side, x1 equal to x2, right?
yeah.
Okay, so we are getting f of x1 equal to f of x2 imply x1 equal to x2. So it is injective. Okay, got it?
Yeah.
Right. So now let me tell you the surjective concept. Surjective. So surjective means actually every element of codomain has at least one pre-image.
I'm
Okay.
sorry.
Hmm.
I think you have the Zoom will close. Maybe you're using account that is not
Paid. Yes.
because it says less than 1 minute left. I
Okay.
think from my university account, I can make a longer meeting.
Okay, please. Okay, send me if you have link.
Okay.
Okay. Okay.
Can you see these notes?
Yeah, I send. I will send. I will send. Yes. Okay.
Okay, I will make a link now.
Okay. Okay.